Welcome to Konko Academy. In this tutorial, I'll be taking you guys through dot and cross products of vectors. And under dot and cross product of vectors, we'll be explaining some concepts that are required in vector calculations. Now, if you are new to this channel, I recommend that you subscribe to the channel and put us on post notification so that you'll be notified whenever we upload a video. Now back to this tutorial. Suppose we have a vector. Suppose we have a vector A, which is equal to, say, A1, A2, A3. This is a three-dimensional vector. We are using three-dimensional so that when you get a question in two-dimensional, it will be easy for you. Now, and B, which is equal to B1, B2, B3. Concepts that are applied to three-dimensional can be applied to two-dimensional. Just that for three-dimensional, the calculations are a bit complex. Now, suppose we are asked to find the dot products of A and B. This is how we write the dot product of A and B. Now, suppose we are asked to find the dot product of A and B. What we do is that we multiply the x component of A to the x component of B, so we multiply the x component of A to the x component of B, then the y component of A to the y component of B, then the z component of A to the z component of B. So we are going to get A1 multiplying B1 plus A2 multiplying B2 plus A3 multiplying B3. That will give you the dot product of A and B. Now let's take an example. So A is equal to 1, 2, 3. Then B is a vector which is equal to, now pardon me if I don't bring the arrows, I still mean vectors. You will have to bring the arrows when you are writing for vectors. So B4, 5, let's say 3. Now if you are asked to find the dot product of these two vectors, A dot B, what you do is that you multiply the 1 to the 4, then you add it to 2 multiplying 5, then you add it to 3 multiplying 3. So we get 1 times 4 plus 2 times 5 plus 3 times 3. So we get 4 plus 10 plus 9, which is 23. So this, our dot product is 23. And the dot product of two vectors is going to give you a scalar. Please put this in your mind. This is a concept that you have to know. The dot product of two vectors is going to give you a scalar quantity, but the cross product of two vectors is going to give you a vector. The dot product of two vectors is going to give you a scalar, and the cross product of two vectors is going to give you a vector. Okay, now we are going to use the dot product for an application. Now we can find the angle between two vectors using the dot product concept. Now the angle between two vectors, let's say A and B, as we've always been using, the angle between these two vectors A and B can be gotten from the dot product of these two vectors. So A dot B, and you should equate that, this is a formula, to the magnitude of A, the vector A, multiplying the magnitude of the vector B, multiplying the cosine of the angle between those two vectors. the dot product of these two vectors should be equal to the magnitude of these two vectors multiplying the cos of the angle between the two vectors. Now we can rewrite this vector as unit vectors, as we already know. So we can rewrite them as a, this vector divided by the magnitude of the two vectors plus, b divided by the magnitude of b, which is equal to the cosine of the angle. Now, if you recognize this from the previous video, the vector a divided by its magnitude is what? The unit vector of a. And this one will give you the unit vector of b. And that should be equal to the cosine of the what? The angle. Okay. We can make some deductions from this formula. Now you can see that, let's say theta is equal to 90. If theta is equal to 90 degrees, what do we get for here? If theta is equal to 90 degrees, means the two vectors are what? Orthogonal or perpendicular. If the two vectors are the angle between the two vectors is equal to 90, it means the two vectors are perpendicular. And if two vectors are perpendicular, it means that we can deduce from this formula that their dot product is equal to 0. Since cos 90 is 0, it will multiply this, giving this expression to be equal to 0. So it means their dot product is equal to 0. So this is a property. If two vectors are perpendicular or orthogonal, it means that its dot product should be equal to 0. Okay. Now for the cross product, we will be doing that in the next video. Now this video will be broken into two, but I want to teach a short trick for cross product of some vector component. We know that if you have a vector component a, which we've said that a is equal to a1, a2, a3, we can rewrite it as a1i plus a2j plus a3 k. Okay, so we have something called the cross product of this I, j, and k. Now this is a shortcut I want to treat before we reach the cross product in the next video. So I, j, k. Now I'm drawing something here in the anti-clockwise direction. Now say we have I cross j. Now if we move in the anti-clockwise direction, the answer that we get is positive. This arrow signifies a cross. So this arrow signifies a cross. If you move in the counterclockwise direction, it's positive. If you move in the clockwise direction, it's negative. So I cross j is going to give you what? K. I cross j is going to give you k. Now we know this from the diagram. Please follow the diagram. Now say j cross k is going to give you I. J cross k is going to give you I. So j cross k is going to give you I. Now let's say we are doing it in the backward position. So I cross k. That's I cross k is going to give you negative j because we are going against the arrow. So I cross k is going to give you j. Now put your answer for k cross j in the comment section. Put your answer for k cross j in the comment section. Now we'll be doing another video for the cross product. Thank you for watching to the end. Kindly share this video to your friends who have problems in vectors, and also like, comment and subscribe. This is Okunku Academy.